everybody, let's talk about how to check solutions to a system of equations. So where this is important is, let's say you've solved by either graphing, by substitution, or elimination. What you're doing here is you're taking your answer that you got and you're going to check to make sure it is correct. So two examples for you here. We're going to check whether the provided solution is a solution to the system of equations. So here's our system of two equations, x plus y equals 8, 3x minus y equals 0, and we have this solution 2, 6. And remember, the first value is our x value, the second value is our y value. So we have x is 2 and y is 6. How we're going to check our solution is we're going to take these x and y values and plug them in for x and y in our equation. But here's the catch. You're not just going to plug it in for one of the equations. You're going to plug it in for all the equations in your system. So here we go. So my first equation in the system is x plus y equals 8. So if I plug in 2 for x and 6 for y, I'm going to have 2 plus 6 equals 8. If I add these together, 2 plus 6, cleaning up the left side, I get an 8. And on the right, I just had a plain old 8 in the first place, so I end up with 8 equals 8. So far, so good, because 8 does, in fact, equal 8. So we got what we wanted here. But again, I have to check all equations in the system, so now I'm going to check my second one. 3x minus y equals 0. So I'm going to plug in a 2 for x, a 6 for y. So we're going to have 3 times 2 minus 6 equals 0. Cleaning up the left side here, I'm going to have 3 times 2, which is 6, minus 6 is equal to 0, and 6 minus 6 is 0. So I end up with 0 equals 0, which in fact 0 equals 0 is true. So what that means when it works for both equations there, it means this 2 comma 6 is a solution. So that's what it looks like when you do get a solution. Now on to my second example. So I have a new system here, two equations, and a proposed solution, 8, 2. So my x is going to be 8, my y is 2. So what I'm going to do is I'm going to take this point, plug it in, see what happens. So I have x minus y equals 6. If I plug in 8 and 2 for x and y, I have 8 minus 2 is equal to 6. Subtract here, 8 minus 2 is 6, is equal to 6. So far so good. 6 is equal to 6, that is true. So far this solution works at least for one of the equations in my system. But remember, you have to check your solution with all equations in the system. So my other equation, 2x minus 10y equals 4. Plug it in 8, plug it in 2. I'm going to have 2 times 8 minus 10 times 2 is equal to 4. So 2 times 8, 16, 2, or 10 and 2, so I have minus 20 equals 4. Just doing some basic simplifying here, 16 minus 20 is negative 4. So I end up with negative 4 equals a positive 4. I see 4s there, but with one being negative and one being positive, those are not equals. Those are different numbers. So my solution worked for one equation, but not all the equations in the system. So what this means is 8, 2 is not a solution. So that is the process of checking your answers on this system of equations problems. Why that's helpful is, when you're doing either of these problems by graphing, elimination, and substitution, you don't need to ask anyone whether you got it right or wrong. You can check your solution yourself and figure out if it's correct or not. And again, that was checking solutions to a system of equations.